Hello dear students. Now I am going to teach you a very important subject in civil engineering, that is steel structures. So steel structures are very important when you especially look for industrial structures. Look at any industry, any kind of industry for that matter, most of the time we prefer to go for steel structures. And look at transmission towers, we can have signal based transmission towers and we can have even electrical transmission towers basically to carry the electrical cables. So, and you can look at, for that matter, railway bridges especially. When you look at railway bridges, essentially they are made of plate girders basically, okay? And we can have even truss girder type bridges as well. So, these steel structures has certain advantages when compared to the reinforced concrete structures. Most of the structures, if you look at practically outside the world, most of them are made of reinforced cement concrete. But still, however, we need to have even the use of steel structures for specific applications. It has its own advantages when compared to the reinforced concrete structures. So, we will look at what are the advantages of steel structures when compared to the reinforced cement concrete. Before going to that, let me tell you about what is the importance of this subject for the competitive world. For example, if you write any exam, it may be GATE exam or engineering service examination, or it may be SSC or any state level PSUs, etc. Okay. So, first let us see the weightage for these steel structures. The weightage of this particular course, steel structures, for the GATE examination, if you look at GATE examination, the weightage for this subject is 5 plus or minus 1. So, typically we can say 4 to 6 marks is the general weightage for this particular course. Sometimes it may be more also, but I am saying on an average for from steel structures, you will be getting 4 to 6 marks for the GATE examination. And if you look at ESE, Engineering Services Examination, the weightage for this course is around roughly 13 to 14 marks on an average, I am saying. And it has good amount of weightage if you write any state level examination, SSJE, etc. Okay, so therefore, it has good amount of weightage for the competitive examinations, and it may be very higher even if you look at state level examination. It is like that. Okay, so what I suggest to is, because it has good amount of weightage, what I suggest to is I will be giving you what are the contents I am going to tell in this entire course, and I will be teaching you each and every module in a very systematic way and in a well organized way, so that you can learn it in a very systematic way. And I will be mostly explaining the concepts, how each and every formula came in this particular course, so that you need not to mug up anything, just follow the concepts, apply the concepts, you can be able to derive the formula on your own. In that fashion, I will be teaching this particular course. So, to begin with, first I will be dividing this particular steel structures into several chapters. First thing is materials and specifications. So, what are the materials we are going to use for steel structure construction, and what are the specifications given by Indian standard in order to use that steel as a structural steel for construction of steel structures. There are certain specifications, and which section to be used at what location. For example, if you have a tension member, for tension members, which section you have to use. Suppose if you have a flexural members, bending members, what member I have to provide as a bending member, bending resisting member, I can say. And if there is a torsion comes, which section I have to provide in order to resist the torsional effects comfortably, safely. And sometimes you may be having a special forces, combination of forces, combined stresses. In such cases, what sections you need to go for. Okay, so I will be dealing everything in the first chapter of materials and specification. Okay, then thereafter you will be going for the second module, bolted connections. The third module, module welded connections, etc. and so on. We have tension members, we have compression members, and we have basically flexural members, beams, how to design beams, and how to design eccentric connections, how to design plate girders, how to design gantry girders, how to design compression members, especially column bases also in addition to the built up columns. Okay, and what are the roof trusses we are going to use, what are the design things we have to take care of when you go for roof trusses. Okay, so all these things will be covered in steel structures. Okay, so now without wasting your time, let us start with the first chapter, that is materials and specification. So for steel structures, what are the materials we are going to use and what are the specifications given by Indian standard? For that, let's see as a first module, that is materials and specifications. So this is the first module for us, and now let us see one by one. What is a steel structure first? What is meant by a steel structures? Let us talk about what is meant by a steel structure. So when I say steel structure, it means a structure. What is structure basically? To begin with, what is a structure? It is a combination of set of elements or members. Okay, set of elements or members are combined or connected together so that a system is going to form, and that system should have sufficient strength and stability. Whenever you apply a force, it should be in a position to withstand those forces without undergoing much deformations. It must have stability. That is what we call basically as a structure. So structure is a combination of elements or members which are able to resist the deformations caused by the external forces or combination of forces, we can say. That is what we call structure. Now coming to the what is a steel structure? A particular structure which is constructed by using steel material, then we call it as the steel structure. But what kind of steel it is? So basically we have something called as hot rolled steel sections. I can define steel structure in this fashion. A structure, it's a structure constructed by using hot rolled steel sections. Structures constructed by using hot rolled steel sections. Okay, so the structures which are constructed by using hot rolled steel sections are basically called as steel structures. What are these hot rolled steel sections? Once again, the question mark here is, what are the hot rolled steel sections? Why we name them as hot rolled sections? Very simple. So because you have a steel. Let me start with how do you manufacture a steel? So when you want to manufacture a steel, we need to have some ingredients. So let us begin with, suppose if I have a steel, you take a steel, how do you get, what is the typical composition of steel? Let us look at that first. Steel majorly consists of iron. The major ingredient for steel is iron. Then we need to add carbon essentially. So carbon content we need to add. Certain amount of carbon content we have to add, and then we need to add even manganese, sulfur, phosphorus, chromium, nickel, and copper. So these are all added. If you add these things to the iron and as well as carbon, then we are going to get a steel. So this is how steel is being manufactured. So this iron we are going to get from mining, you know that, okay. This raw iron is being purified because it has some impurities, we need to remove that. Then after that we take the pure iron ore, and then we will be adding carbon content, and we will be adding all these things, manganese, sulfur, phosphorus, chromium, nickel, copper, silica, etc. according to the need of, or according to the quality of steel what we desire to have. Then we will be adding these things. Then we will be heating them, and the proportions are appropriately maintained. Then we will be getting a material which is called as a steel basically. And coming to the point here, some of the examinations they are asking what is the percentage of iron in steel. So the percentage of iron in steel is typically more than 98% by weight. So please understand, dear students, this iron has more than 98% in the steel by weight. It's not by volume. What is the meaning of by weight? When I say by weight means, if I take 100% of the steel, let's say for example, if you want to understand, let's say I take a steel of 100 kg, in that more than 98 kg you will be having the iron basically. And then look at here, we'll be adding carbon, and the carbon content typical range is 0.1 to 1.1 percentage. This is the carbon content typically we are going to use for construction of steel structures. Okay, and the carbon content is very, very important. It is going to influence the mechanical properties of the steel. So carbon content, if you increase or decrease in the manufacturing process of steel, it drastically changes the behavior of the steel. That is the biggest problem we are having. We must be very, very careful. It is like a poison. Carbon content, even though you look at poison, if you take very small magnitude also, it causes fatal or death to a particular being, right? Individual, whatever it is. Something like that. For the steel, it is like that. Even small percentage of carbon content change is going to change the behavior of the steel very drastically. So I'll tell how it is going to influence carbon content, the mechanical properties of the steel. I'll come to that. Then we'll be adding manganese, sulfur, phosphorus, and chromium, nickel, and copper. So these are added, manganese, sulfur, phosphorus. They are added for hardness purpose, to increase the hardness of the steel, and weldability purpose as well. Weld. When you want to do connections, there are two things essentially. Nowadays, as per the latest code IS 800-2007, we have connections of two types. One is a bolted connection, the other one is the welded connections. But coming to a particular case of chromium, nickel, and copper, we will be adding these chromium, nickel, and copper to act as anti-corrosive agents, or I can say even stainless steel essentially. So this chromium nickel content will be high in case of stainless steel when you want to manufacture, but in case of normal structural steel, they have very, very minimal percentage. We can say very, very minimum, 0.01, in that range we will be having this percentage. Okay, we can say very small amount. I can say trace in amount, we can say, people say that. Now coming to the point here, as I told you, this is only 0.1 to 1%, 1.1 percentage, but it drastically changes the mechanical behavior of the steel. So this carbon, we need to pay certain attention, and some of the questions are asked based on this carbon content, how carbon content influences the properties of the steel. So as I told already that carbon content influences, let me tell, carbon content influences only mechanical properties. Carbon content influences only mechanical properties of steel. Mechanical properties of steel. So what are the mechanical properties and what are the physical properties? Let's look at that first. Then I'll explain how carbon content is going to influence those properties. Okay. So let us start what is the mechanical properties and what are the physical properties. Suppose if I start with let's say physical properties. So what are the physical properties of a steel and what are the mechanical properties of the steel? So when I talk about physical properties of a material, what comes into picture? What are the physical properties? Can you think please and tell me what are the physical properties? Don't say color, texture, etc., but engineering things. So here basically physical properties, when I talk about physical properties, I have something called as mass density. Okay, so we have mass density is a physical property of the steel, and we have specific gravity, that is also the physical property of a steel, and we have even what we call Young's modulus or modulus of elasticity. Young's modulus, or we can also call as modulus of elasticity. We typically represent with capital E symbol, and we have modulus of rigidity, we call it as modulus of rigidity, or it is also called as shear modulus. We represent with symbol Z or C, okay, depends. And we have even Poisson's ratio, and we have Poisson's ratio in the elastic range and plastic range. We represent with symbol mu. And then we have quotient of thermal expansion. Coefficient of thermal expansion. So, coefficient of thermal expansion, that is basically what we call as alpha. So, these are all the physical properties of a particular material, any material you take it. For steel, there are some questions appeared in competitive exams. What are the physical properties of structural steel as per IS 800-2007? Let us see. We have mass density. So, what are the mass and the corresponding values? I am writing what are the corresponding values of these physical properties. Let me write it in the form of table so that you can remember them easily. So, I will be dealing everything in a very systematic way. Please follow them. Try to understand them. All these are as per the codal provisions. Mass density of the steel as per IS 800-2007, it is 7850 kg per meter cube. That is the mass density of the steel, structural steel. And what is the specific gravity? The specific gravity of the steel is, as we know that specific gravity is density of a material by density of a standard substance. That is what water basically. Water's mass density is 1000 kg per meter cube. Just divide density of the steel with density of water, that is 7850 by 1000, it gives 7.85 is the specific gravity of the steel. Now, what are the Young's modulus of the steel or modulus of elasticity of steel, which is equal to 2 into 10 to the power 5 megapascal, or we can say Newton per mm square. 2 into 10 to the power 5 megapascal or Newton per mm square. And modulus of rigidity, or it is also called a shear modulus, which is also called a 0.769 into 10 to the power 5 megapascal, which is Newton per mm square. And then we have Poisson's ratio. This Poisson's ratio mu is having two ranges. One is the elastic range. In the elastic range, we have some Poisson's ratio limit, and we have in the plastic range, we have another value. So, the Poisson's ratio in the elastic range was 0.3. The Poisson's ratio for steel in the plastic range is 0.5. So, this is the typical range of Poisson's ratio. Please remember, they are asking these questions in the competitive exam. So, that is why all these values you have to remember. And the quotient of thermal expansion of the steel, which is 12 into 10 to the power minus 6 per degree centigrade, per degree Celsius. These are the physical properties of the steel, which are given as per IS 800-2007. As per the latest code for design of steel structures, IS 800-2007. What is this IS 800-2007? This IS 800-2007 is the code of practice for design of steel structures. This is the code of practice for design of steel structures as per limit state design. So, for design of steel structures, we have to follow strictly the guidelines of IS 800-2007, and this is as per limit state design. So, this code is as per limit state design, and we have even working stress method also. That was old code. Nowadays, we are not using that. IS 1984 was there earlier, and it was revised in the year 2007. And the same guidelines we are using nowadays for all steel structures construction. Okay. So, please remember, one of the gate question, and in other ESC also they ask this question: what is the ratio of Young's modulus to modulus of rigidity of structural steel? That is the question asked in the gate exam earlier. How do you answer this question? So, values are known to you. They ask the question, what is the ratio of Young's modulus of the steel to the modulus of rigidity of the steel. Very simple. This is the ratio 2 into 10 to the power 5 by 0.769 to the power 5. That will give approximately 2.7 is the answer. So they may ask questions from any of these. So please remember, these are the standard values, very simple. And typically, most of the time we will dealing with structures in the elastic range, but not in the plastic range, because in the plastic range there is a possibility of failure. So the Poisson's ratio of steel in the elastic range is 0.3. Please remember this. This is also asked in some of the exams. Please do understand this. Now, let us go with, these are all the physical properties, but the carbon content does not influence the physical properties of the steel. So, physical properties for a particular material remains same as it is. Okay? Please understand that. Now, what are the mechanical properties? Let us look at that also. So, what are the mechanical properties of the steel? Let us see that. Mechanical properties of steel. What are the mechanical properties of the steel? What comes in mechanical properties? So, all the strength characteristics and all the performance based characteristics will comes under mechanical properties of the steel. So, these are very, very important for material. So, all strengths, so strengths are of two types. Basically, if you look at strengths, strength may be of two things. One is the ultimate strength. One is the ultimate strength. The other kind of strength is basically what we call as yield strength. Two things are there. One is the ultimate strength, the other one is the yield strength. So, yield strength we designate with symbol Fy, and ultimate strength we designate with symbol Fu. So, these are the two strengths we are having. So, strengths comes under mechanical properties, and this strength is influenced by carbon content. As I told you, mechanical properties are influenced by carbon content. Please underline this. Remember this, influenced by carbon content. Okay. So, how it is going to influence, I will explain. But what are those mechanical properties? Let me list out, and then we will see how these are going. These are influenced by carbon content. The second thing is that we have not only strength aspects, the other aspects like hardness. What is hardness? First, what is mean by strength of a material? So, resistance offered by a material against a failure is what we call as a strength of a material. We know that everybody might be knowing about it. It's a very common thing, generalized thing you might have learned at your BTech second year itself. Strength of materials, right? What is the hardness basically? What is the meaning of hardness? So, the resistance offered by a material against wear and tear action. Wear and tear and rubbing action, abrasion action. What is the resistance offered by material against that kind of shearing effect, abrasion effect, wear and tear effect is basically what we call as hardness. And we have something called what we call as ductility. So, what is ductility? What is the meaning of ductility? Resistance offered by a material against abrupt failure, sudden failure, and the material has a tendency to undergo large deformations, or we can say large tensile strengths when a tensile force is applied. Such kind of property is basically what we call as ductility. Okay, and we have something called brittleness also. What is the brittleness? That means brittleness in the sense it is the tendency of a material to fail abruptly, suddenly, what we call catastrophic failure. So, sudden failure of a material, whenever you apply tensile force, it simply breaks into two pieces. That kind of material property is what we call as brittleness. Okay, and we have something called as toughness. Toughness. What is the meaning of toughness? Resistance offered by a material against impact loading, sudden loadings, is basically what we call as toughness. So, ductility and toughness, these two are basically very proportional to each other. If a material is ductile, it is also having enough toughness. More ductile, more toughness also it possesses. So that is what you have to understand. Okay. Now let us see how our carbon content, it's a very important thing. This is asked in several competitive exams. How this carbon content is influencing these mechanical properties. Let us look at that. So, dear students, you have to understand one point here. The carbon content, if you look at what is the strongest bond on the earth. So, when I say strongest bond on in a material, or we can say what is the hardest material on the earth, the answer is diamond. Okay, so diamond. So diamond is having carbon bond basically. It has carbon bond. That's why it is very very hard. So that is what the significance of carbon is. So what does the carbon do is carbon makes the atoms to be closely packed in the crystalline structure or in the microstructure basically. If the atoms are very closely packed because of this carbon content in a material, as long as the atoms or molecules are being closely packed, the voids gets decreased. If the voids gets decreased, then what will happen? Strength will increase basically. If the voids are less in a material, strength will be more automatically. Okay, I hope you understand that. So that is what it is. When you go for higher carbon content, more possibility of having closer bonds and no chance of having any voids. If there are no voids, we can say that that material is very very strong. That's why strength will improve when you go for increase in carbon content. If the carbon content is more, the strength is also more. Please understand, both ultimate strength as well as yield strength, both will be more when you go for the higher carbon content. Coming to the hardness, as I told just now, if the carbon content is more, atoms are also closed packed, very densely. What happens then when you pull it? So what is the meaning of hardness? Resistance against shearing action or abrasion action. So when you try to make rubbing action on a material which is very closely packed, where atoms are very closely packed, it will not come out. It will not undergo wear and tear. So therefore, what happens is, if the carbon content is more, the resistance to wear and tear action is also more. We can say that hardness is also more. So these are the very very basic important points which you have to understand. So when the carbon content is increasing, strength increases, hardness also increases. These are the two benefits we are having. So higher the carbon content, higher will be the strength. What strength? It may be yield strength, it may be ultimate strength. Both the strengths will be increased when you increase the carbon content. And one more thing, when the carbon content is increases, hardness also increases. Please understand that. Now coming to ductility. As I told, what is the meaning of ductility? Definition for ductility, as I told you already. When I say ductility, the resistance or resistance offered by material against complete failure, sudden failure, is called as ductility. Otherwise, the material which has the ability to undergo larger deformations or large tensile strengths before absolute failure when you apply a tensile force. That is called as the ductile material. But what happens? If you increase the carbon content, as I told you, the atoms are very closely packed. So when you try to pull it, the material does not being stretched because the atoms are very closely packed. So that means this tendency to elongate is going to decrease when you increase the carbon content. Are you getting the point? So that's why ductility reduces. So ductility reduces when you go for the increase in carbon content. As I told, ductility and brittleness are exactly opposite to each other. If the ductility reduces, brittleness increases. Brittleness means failing suddenly when you apply force. So that will be increased when the carbon content is more. And toughness, as I told, ductility and toughness are proportional to each other. If the ductility is less, toughness is also less. So this is what happens when you increase the carbon content. Strength increases, hardness increases. As carbon content increases, this is what exactly happens. So I can summarize over here that I make a note over here that as carbon content increases, what happens? Let us look at that. as carbon content increases, what happens? As carbon content increases, strength increases. What about hardness? Hardness also increases. What about ductility? Ductility reduces. What about brittleness? Brittleness increases. What about toughness? Toughness also reduces. So this is what exactly happens as the carbon content increases. In the reverse way, as the carbon content decreases, what happens? So another note, the second note, this is the first note I given. The second note is that as carbon content decreases, what happens? It's exactly opposite to that. So as carbon content decreases, what happens? As carbon content decreases, the strength is going to decrease, exactly reverse effect. Whatever the effects we have for the increased case, it will exactly opposite this. As carbon decreases, strength decreases, hardness also decreases, and ductility increases. So that's why low carbon steel are highly ductile. Ductility increases and brittleness decreases. Brittleness decreases and toughness increases. So low carbon steel, that means carbon content decreases means low carbon content. That means lowering the carbon content means decreasing the carbon content. So low carbon steels are highly ductile. Please make a note that low carbon steel are beneficial for us in terms of ductility and toughness. So however they have strength, we should not compromise with the strength. Very, very important thing, you look at any structural construction, essentially we have to look at strength first. So strength is a very important criteria. At the same time, it should not fail in serviceability accept, criteria as well. That's very important. We have to compromise with both strength as well as brittleness. So we should have ductility, enough ductility. Otherwise, the system becomes very catastrophic, kind of thing. So lead to sudden failure. We never, being civil engineer, we never expect the structure to fail suddenly. Okay, it should have some reserve strength before absolute failure. So that's what, and that's why we design all structures by incorporating some factor of safeties. Okay, we'll see all those things, very clearly one by one. So this is how your carbon content is going to influence the mechanical properties of the steel. These are the mechanical properties of the steel. Now coming to the, as I told you, steel is manufactured in that way. Now understand, this particular steel can be divided into three categories: low carbon steel, medium carbon steel, high carbon steel, only based on the carbon content. So let us see that also here, that classification of steel. So classification of steel based on carbon content. So how do you classify the steel based on the carbon content? Let us see that. So based on carbon content, we have three varieties of steels. So the first one is, number one is basically low carbon steel. So what is mean by low carbon steel? When you call a steel as low carbon steel, when you call a steel as medium carbon steel, and when we call a steel as high carbon steel. So these are the three types of steel we are having. So when you call a steel as a low carbon steel, typically if carbon content, Cc means carbon content, if the carbon content is in the range of 0.1 to 0.24 or typically 0.25, nearby 0.25 also, that is called as low carbon steel. Whereas if the carbon content is equal to 0.25 to 0.6 percentage, then it is called as the medium carbon steel. Suppose if the carbon content you used is, it is 0.61 to 1.1 percentage, then it is said to be high carbon steel. So, based on the carbon content, we classify the type of the steel. The carbon content is small, it is 0.1 to 0.24 percentage, it is said to be low carbon steel. The carbon content is 0.25 to 0.6, it is said to be medium carbon steel. The carbon content is 0.61 to 1.1%, it is said to be high carbon steel. So, purely based on carbon content, we classify the steel like this. But very important thing is, most of the structural applications, we use either low carbon steel or medium carbon steel, and we do not use high carbon steel. The problem with high carbon steel is that, as I told you, as the carbon content is very higher, the material becomes more brittle. That is the biggest problem. So, for structural applications, high carbon steel should not be used. So, for structural constructions, high carbon steel is avoided. Please understand this, because the structure becomes a or undergoes a brittle failure, which we never expect being a civil engineer. Now, we always prefer to have first construction of steel structures. Essentially, we go with either a low carbon steel or medium carbon steel. So, look at what are the examples for low carbon steel. Look at mild steel bars. We have used previously for reinforced cement concrete, mild steel bars. Those comes under low carbon steel. Okay, so what is the difference between mild steel and HYSD? In RCC, I am not talking about steel structures here, I am talking about general reinforced cement concrete structures. Nowadays, we are using TMT bars, or we can say HYSD bars, and earlier we used to use mild steel bars. Nowadays, we are not practicing them because of poor bonding property with the concrete. So, this mild steel bars, which we have used earlier, comes under low carbon steel. And most of the structural steel which you are using for steel structure construction, okay, for steel structure construction, we are using basically structural steel. That structural steel, mostly, not all of them, but mostly they comes under low carbon steel. That means which are highly ductile. And medium carbon steel we use very commonly in our daily life. So, you look at hammer, which we are using for different applications, workshops, wherever it is, for normal household purpose also. Hammers we use. So, hammers which is made of medium carbon steel. You look at rails in railway tracks, rails are made of medium carbon steel. Even train, most of the wheels and other parts are made of basically medium carbon steel. Likewise, many things, HVAC bars in RCC construction, TMT bars in RCC construction, all those materials basically made of this one, medium carbon steel. And high strength steel used in pre-stressed concrete as well as steel structure construction, those are also comes under medium carbon steel. But high carbon steel, we are not using for structure construction. Then you may ask, then sir, where we can use high carbon steel? So basically this high carbon steel is having higher strength. As I told, as the carbon content is more, strength is more. So, high carbon steel has high strength. This high strength steel is very much essential for drilling holes. That is why punching machines, drilling machines, bore holes, or any other missions which are going to make the material to crush, something like that kind of constructions, that kind of use, we go for high carbon steel. All kind of punching machines, drilling machines, basically made of high carbon steel. Okay, but for structural applications, we use only these two things. These are used for structural applications. Please understand this. Only we prefer to have these two. Whereas for non-structural applications like drilling machines, punching machines, any kind of works, that kind of works where strength is more, strength is very important thing. Okay, bore holes if you want to make. Okay, all these things basically comes under high carbon steel. Fine. Now come to the point. This is the classification of steel based on the carbon content. Now, if you look at basically, I told something called as hot roll sections. Let us talk about what are the hot roll sections. So, before that, let me tell one more thing here. What are the stress strain curve for this kind of steel? Low carbon steel, medium carbon steel, high carbon steel. How the stress strain curves looks like. So as I told just now about what are the material properties, what happens if the carbon content is more, what happens? If the carbon content is less, what happens? If the carbon content is more, what happens? So when I draw stress strain curve for these types of steel that is based on carbon content, what happens? If we take low carbon steel, they have proper yielding. This is what it is. This is low carbon steel. And you take medium carbon steel is of something like this. It has more strength, little high strength. There is no doubt about it. Apart from that, essentially, it does not have much elongation, but it has very limited deformation in the strain. So we are drawing stress strain curve for materials. So when I draw stress strain curve, I have to basically keep my stress on the y-axis and strain on the x-axis, because independent parameters should be there on the x-axis, dependent parameters should be there on the y-axis. And when I talk about basically high carbon steel, basically it has high strength, but it has very low tensile capacity. It will fail like this. Abrupt failure will happen. So dear students, what you have to notice here is that this has this much strength. See, this particular plot, whatever I have drawn in the beginning, this is the example for low carbon steel. These are the low carbon steels, and this is the medium carbon steel, and this is the high carbon steel. Okay, these are the types of steels we are having based on carbon content. Look at here, this low carbon steel has limited strength. See, when I draw this kind of lines, horizontal lines from, this is the ultimate strength for this low carbon steel. So strength is less among all these. This is the ultimate strength for medium carbon steel. This is the ultimate strength for high carbon steel. So high carbon steel is having high strength, no doubt about it. And if the carbon content decreases, strength is decreasing, ultimate strength. It's fine. But coming to their tensile part, strain part, it's very small for the high carbon steel. High carbon steel has only failure happened here itself. That means it has very less strain. Strain means deformation. They break suddenly, without much strain. Medium carbon steel, it has good amount of strength. It is going to fail relatively medium strains. And low carbon steel, it has large strain and it fails. That's why these are highly ductile. Fine, I hope you understand what is the difference between these steel based on carbon content and their performance as well. Now, as I told you, when I explained about what is the steel structure, basically I told that, so when you go to the definition for steel structures, as I told that, see here, this structures constructed by using hot rolled steel sections are called as the steel structures. I told that is how I define steel structure. The structures which are constructed by using hot rolled steel sections are called as the steel structures. That is what I told. Now coming to the process, then after that I started explaining about what is the steel, what are the different types of steel, what are the physical properties, what are the mechanical properties, how low carbon steel, how medium carbon steel, how high carbon steel behaves, and what are the practical applications. I told all those things. So we are going in a very right path, in a systematic way. Now let me define what is hot rolled steel sections. So all structures, steel structures, which are constructed by making use of only hot rolled steel sections, such kind of sections are called as the steel structures. Now what is the hot rolled steel sections? Let us look at that once again. What are these hot rolled steel sections? What are the advantages of this hot rolled sections? Let us talk about what does it is, what are the advantages of steel structures when compared to rest of the RCC material. Let us also discuss about that also here. Come to the point here. Hot rolled steel sections are made of structural steel. Hot rolled steel sections. So steel structures are constructed by using only hot rolled steel sections. So hot rolled steel sections are made of structural steel. Hot rolled steel sections are made of structural steel. Okay, please understand that. So the structural steel is used for preparation of hot rolled steel sections. What is mean by hot rolled steel section? Very simple. You take the steel is being subjected to heat, tremendous heat. In the steel plants, okay, where steel manufacturing process happens, there we will be taking all ingredients of iron, carbon, manganese, sulfur, phosphorus, etc. We will be heating them at very tremendous temperature of 750 degrees Celsius and even more than that. And then all these materials are mixed, and that material which is in molten state is being subjected to a set of rollers. So basically there are a set of rollers that are there, and these rollers through which this particular steel material is passed through are passed under these rollers, and these rollers will convert this material into the required shape and size. Rollers may be not only horizontal, rollers may be even vertical, which are going to convert this particular material into required shape and size. That kind of sections, we may get I sections like this, we may get I section if if the steel undergoes rolling process. We may get channel sections, we may get angle sections, etc. We may get tubular sections, etc. This is what exactly happens. So all these things are essentially, we call them as hot rolled steel sections. We call them as hot rolled steel sections. Hot rolled steel sections. These hot rolled steel sections we are going to use for the construction of steel structures. So what is a steel structure? Listen, not only these 4, we have 10 types of hot rolled steel sections. Basically, we are getting from Indian rolling mills. So any steel structure you want to construct, you take a few of them or all of them according to the nature of construction, type of construction. We can use all of them also sometimes. So such kind of structures which make use of these hot rolled steel sections are basically called as steel structures. Fine? Okay. I hope you understand why we are calling them as hot roll, because they are heated. We can say red heat, we can say. The steel undergoes hot process, tremendous temperature, and then it is in molten state. Then here these are what we call as rollers. These rollers are converting this material into the required shape by undergoing heating process. That's why whatever the sections we are getting by this process, we call them as the hot rolled steel sections. I hope you understand. And steel structures are constructed by only using hot rolled steel sections. Fine, I hope you understand this. Now let us talk about what are the types of structural steel. So I told that structural steel is the steel used for the manufacturing of these rolled steel sections. What are the structural steels we are having? Let us look at that first. Then after that, we will be looking for what are the advantages of steel structures when compared to the reinforced cement concrete. So that will be in a very systematic way. Okay. Now let us go with what are the types of structural steel. So let us talk about that. Types of structural steel. So types of structural steel. So what are the different types of structural steels? What are the grades otherwise we can say? So if you understand properly reinforced cement concrete design, what are the different types of reinforcing steel? What are the meaning of different types of reinforcing steel? So we can use different types of steel for construction of RCC structures. What are the steels that we are going to use for RCC structures? Very simple. We have mild steel, we have HOSD steel, we have TMT steel, etc. In HYSD we have grades. What are those? 415, FE 415 steel, FE 500 steel. I hope you know all these things. If you do not know, also doesn't matter. I will be discussing all those things in the reinforced cement concrete subject. Okay. So, if you look at RCC, for the construction of reinforced cement concrete, what is the reinforced cement concrete? Concrete is there. Into that concrete, we are going to embed the steel bars because concrete is a brittle material which fails because of the tensile stresses. So, to avoid that kind of failure, we embed the steel bar into the concrete. So, concrete is very strong in compression. Whenever compression comes, concrete involves to take the compressive stresses. Whenever tension comes in RCC, any structure, steel bar will take the tensile stresses, so that all the stresses will be taken care by the material itself. So, material absolutely will not fail. That is the main concept of reinforced cement concrete. For that construction of reinforced cement concrete structures, we have different grades of steel we can use. One is the mild steel, another one is HYSD steel. We have grades in HYSD, that is FE 415, FE 500, FE 550, etc. This is how we can classify the reinforcing steel. Now, coming to the structural steel, what are the different types of structural steels? So, structural steels are the steel which we are specifically using for steel structure construction. Okay? Very important thing, please understand, don't get confused, because I am saying here clearly, in order to differentiate reinforced concrete structures with the steel structures, I am giving examples of both. So, reinforcing steels, we have category mild steel, HYSD, TMT, and in HYSD TMT 2 grades 415, 500. That means reinforcing steels are represented by their yield strength. When I say mild steel, typically, okay, so I'll come to this point later. So I want to tell here that RCC steel, or I can say I can write here in the form of note otherwise, so that you can have clarity about what I am talking about. So reinforcing steel. So when I talk about reinforcing steel, we have different grades in it. We have something called mild steel, and we have HYSD steel, high yield strength deformed steel. And in HYSD we have, so mild steel, what is the grade of this? FE 250. This is the mild steel. And HYSD we have two grades. One is FE 415 and the second one is FE 500. Likewise, we have even TMT bars also. TMT bar, these are also grades in it. Okay. So these are the types of reinforcing steel we are having. Please make a note of this and understand this. And how to designate reinforcing steel. So very important point is that reinforcing steel. So reinforcing steel is designated by its yield strength. So reinforcing steel is designated by its yield strength. Please remember that all kind of reinforcing steels are basically designated by the yield strength. Please understand. See, this number 250, this number refers to yield strength. 415, this number also yield strength. 500 is also a yield strength. So all reinforcing steels, this is how we are classifying, and this is how we are designating. Fine. But coming to the structural steel, we have different types of, these are the types of reinforcing steel. I am teaching in this way so that you will not get confused. So, and I told you very clearly what the code we are using for reinforced cement concrete structural design, IS 456-2000. So, as per IS 456-2000, that is a reinforced cement concrete design, reinforcing steel must be designated by its yield strength. Whatever the numbers you are seeing here, all of them are the yield strengths. Now, let me define what are the types of structural steel and how do you designate them. These are the steels we are using for steel structure construction. So, our IS 800-2007 plays a role here, okay, not IS 456. There IS 456 comes because it is a RCC structure. But now we are talking about steel structures. What are the types of structural steels we are having? Let us talk about that. So, structural steel which we are using for steel structure construction are also of three types. Something like RCC, we have three types, three varieties: mild steel, HYSD, TMT. In a similar fashion, structural steel is also having three types. So, types of structural steel, the first one is standard quality steel. What is the first one? Standard quality steel. So what is the standard quality steel? This is one of the structural steel we are using very frequently for the construction of structures. So it is most commonly used steel. It is, I can say it is most commonly used steel. It is most commonly used steel for general construction purpose. Most commonly used steel for general construction purpose of buildings, bridges, industrial structures, transmission towers, okay, towers, signal towers, etc. etc. So this is the very commonly used steel for all general construction purpose and specifically to bridges, industrial structures, transmission towers, etc. And how to designate this standard quality steel? So if you want to refer to the material properties of standard quality steel, there is a separate code IS 226. You can refer to that. All the properties, how it is being manufactured, what are the properties of standard quality steel, all these things are clearly mentioned in separate code IS 226. Need not remember this code, not required, but understand that one of the type of structural steel is standard quality steel. And listen, to manufacture this kind of structural steel, the carbon content, I told na, when you want to manufacture a steel, we need to have certain amount of carbon content. So you need to have carbon content in the manufacturing of this steel. The carbon content used in the manufacturing of this steel is typically in the range of 0.23 to 0.25 percentage. That means which comes under low carbon steel basically, okay. And the percentage elongation, then comes percentage elongation. So the percentage elongation of this particular steel could be of around 23 percentage. So 23 percentage is the percentage elongation of this particular standard quality steel. So let me tell dear friends, I'll specify percentage elongation is very important parameter to define whether the material is ductile or brittle or intermediate ductile. Okay, I will come to that, I will explain about this later. Please understand, if any material, for the time being, please understand this, if any material which shows a percentage elongation more than 15 percentage is a ductile material. Okay, please understand, I will explain that once again clearly. But percentage elongation of this particular standard quality steel was found to be from this code, it is 23 percentage, which is more than 15 percentage. That means it is a ductile material. Any material whose percentage elongation is more than 15 percentage, that kind of material is said to be ductile material. So standard quality steel is a ductile material. Fine. So these are okay. Then how do you designate standard quality steel? The question comes, this is the structural steel. Reinforcing steel, how we designate it? How we designate mild steel? So reinforcing steel also three types are there, mild steel, HY, like that. So structural steel we are using for steel structures, also we have three varieties. First variety is standard quality steel. What is the first variety in RCC? Mild steel. How do you designate mild steel? Some Fe followed by some number. This number is the yield strength for RCC. Similarly, in the similar way, standard quality steel also we have designate with some designation, representation. But what way we are going to designate that standard quality steel? So it is designated as this particular standard quality steel. It is designated as, how we designate this? Very simple. We can designate with symbol Fe410S, or we can also designate simply Fe410. Fe410S or simply Fe410. See, please understand dear students, as per the recommendations of IS 800 2007 or even 1984, IS 800 is the number which tells us the steel code. So as per the steel code, any steel structural steel should be designated with the ultimate strength. So please understand that structural steel should be designated with the ultimate strength. Please make a note, it's a very important thing. Structural steel is designated by its ultimate strength. Structural steel is designated by its ultimate strength. Please understand this. This 410, whatever the number you see here, this number is the ultimate strength. So please remember this. This itself is the ultimate strength. 410 itself indicates the ultimate strength. Okay, whereas reinforcing steel is designated with the yield strength. This is nothing but yield strength. All these numbers are the yield strength. So reinforcing steels are designated with the yield strength. Please remember this. But whereas structural steel is designated with the ultimate strength, FU. Then you may ask question, sir, then how to find yield strength for the structural steel? Fe410 is the standard quality steel. Ultimate strength is 410 megapascal. Here also megapascal. Unit is in megapascal. Fine. Now what about yield strength of standard quality steel? I will explain that. There is a separate table given by IS 800 for knowing the yield strength of the steel. Okay, I will explain that. It's very simple. So this subject is very simple. So you have to understand certain things, you have to remember what are the material properties, everything. These are very basic things. It's already proven by Indian standard based on several researchers effort, it was brought into this stage. So please remember what is already being discovered, and we are going to use design philosophies. There you feel really interesting of this particular course. Okay, fine, come to the point. So standard quality steel is one of the steel we are using for all the general application or general construction purpose of steel structure. This is the one type of the structural steel. Now we have second variety of structural steel. We'll look at even that also. The second type of structural steel is basically what we call as fission welding quality steel. What is that? Fission welding quality steel. So this is the another type of steel, fission welding quality steel. There is a code IS 2062. This is a separate code for fission welding quality steel. We have this code, separate code. Fine. So what is the basic difference between standard quality steel and fission welding quality steel? This particular steel is manufactured only for weldability applications. It has good weldability when compared to the standard quality steel. We can go for welding of any amount of thickness. There is no restriction for weld thickness in case of fission welding quality steel. Okay, fine. Okay. Where we are going to use this fission welding quality steel? It is also used for general construction purpose. So it is also used for general construction purpose. It is also used for general construction purpose of buildings, bridges, industrial structures, transmission towers, etc. Anything, whatever it is. But particularly suitable when there is a welding, particularly suitable for welded connections, best useful for welded connections. And how to designate this? Fission welding quality steel, if you want to manufacture, it also has carbon content. So the carbon content used for manufacturing of this particular steel, fission welding quality steel, typically ranges from 0.2 to 0.25%. It's almost same as standard quality steel. Then percentage elongation. So what is the percentage elongation? So the percentage elongation for this material also 23%, which is ductile. And please understand, dear students, this particular fission welding quality steel has grades. So once again it has certain grades. How to designate? So, we have grades in fission welding quality steel. What are those? Let us see that. So, we have Fe 410 WA, we have Fe 410 WB, we have Fe 410 WC. These are the three grades that are available in fission welding quality steel. W refers to welding, A is the grade, B is the grade, C is the grade. So, there are three grades in fission welding quality steel. A grade refers to the high weldable grade steel and C is the low weldable grade steel. That is what you have to understand. Fine. But if you observe carefully, as I told you that any structural steel is designated with a number of ultimate strength. So, please understand dear friends, this particular steel has ultimate strength of 410 megapascal, this also has 410 megapascal, this also has the 410 megapascal. All the fission welding quality steels are having a ultimate strength of fixed quantity which is equal to 410 megapascal. Please understand that. Now, let us go with the next one, the next type of structural steel, that is basically the high tension steel. High tension steel. So, high tension steel is very important. High strength steel also. People also call it high tension steel. This high tension steel, why you are getting high tension steel here? There is a reason. You know already how do you get high tension strength or high strength, how you are able to get? High strength you can get because of the improved carbon content. When there is improved carbon content, automatically it has high strength. That's it. So, when compared to the previous standard quality steel, fission welding quality steel, this high tension steel is having higher carbon content. If you look at carbon content which is used for the manufacturing of standard quality steel and fission welding quality steel, it is typically in the range of 0.2 to 0.25. Okay? But here, high tension steel is manufactured for high tension carrying capacity. There the carbon content we are going to use around 0.27%. Please understand it. So, dear students, it has high strength, that is very important. It has high tension steel, it has highest strength. It has highest strength and more resistant to environmental effect and more resistant to environmental action and more resistant to environmental action. That's why it is called as high tension steel. Okay? And means high resistant to environmental action means corrosion basically. Now understand dear students, why it has high strength? Because the carbon content used in this is approximately around 0.27%. And percentage elongation, so we have percentage elongation. The percentage elongation of this particular steel is only 20%. Please understand. If you look at the standard quality steel and fission welding quality steel, the percentage elongation is 23%. But here, the percentage of elongation is reduced. Because of what? Because of improved carbon content. See how much was the increase? If you look at standard quality steel, fission welding quality steel, carbon content is 0.25. But high tension steel, just we improved only 0.02%. Then the steel became a high tension steel. See, 0.02% of steel carbon content drastically changed the behavior of the steel. That is what I am trying to say. Small amount of carbon content, fractional percentage of carbon content drastically change the behavior of the steel. That's what I am trying to say. Okay, fine. So, but even then it is a ductile material. Even high tension steel is also a ductile material. Please understand, because percentage elongation is more than 15%. Here it is 20%, therefore it is ductile material. Fine. But it comes under low carbon steel or medium carbon steel. So, high tension steel comes under medium carbon steel because To call a steel as a medium carbon steel, the carbon content should be from 0.25 to 0.6 percentage. So it is there 0.27, which is medium carbon steel. Fine. Now, how to designate high tension steel? So it is designated as, I can say that it is designated as, how to designate? Very simple. It is Fe 570 HT or Fe 570. Fe 570 HT or Fe 570. So this number, whatever the number you finding here, that is the ultimate strength. Please understand this. Number whatever is there is the ultimate strength. Please understand it. These are the different types of structural steel we are using for steel structure construction. Now let us understand. I explained about all the varieties of high tension. Where you are going to use? This is also used where there is the most strength required. Wherever you want to have high strength, there we go for kind of structures. For such kind of structures, we go for the high tension steel. Now, as I explained about all these kind of structural steels, now what are their yield strengths? Let us look at that, because we are going in a very, very systematic way. So, for Fe 570, ultimate strength is 570 megapascal. Now, we are not going to use yield ultimate strength every time for structural strength estimation. We will be using yield stress most of the time. So, if they give structural steel is high tension steel, if you do not know what is the yield stress, you cannot design that particular steel element. So, that is the biggest problem we are having. So, what are the yield strengths for structural steel? Let us look at that. So, I can say type of structural steel. Let us look at that. Type of structural steel. This is the type of structural steel we are having. And what are the thicknesses and what are the yield strengths? So, let me talk about yield strength. And what is the thickness corresponding to that? So, thickness less than 20 mm, thickness equal to 20 to 40 mm, and thickness more than 40 mm. These are the three varieties we are having. Okay. So, what I am trying to say here is that our Indian standard is saying is that this particular yield strength of this particular structural steel is a dependent of thickness of the structural steel section. So, whatever the thickness of the structural steel section we are taking, that thickness is going to influence the yield strength of the structural steel. Okay, please understand it. So, what are the different types of structural steels we are having? The first one, basically we are talking about standard quality steel. We are talking about standard quality steel. For standard quality steel, which is designated with the symbol Fe410, for this Fe410, what are the corresponding yield strengths? So, if the thickness of this standard quality steel is less than 20 mm, then it is taken as 250 megapascal, it is taken as 240 megapascal, it is taken as 230 megapascal. Now, if it is a fission welding quality steel, what is that? Fission welding quality steel. If it is a fission welding quality steel, we have three grades in it. What are those? Fe410WA, Fe410WB, Fe410WC. And third one is high tension steel. These are the three types of structural steel we are having, right? High tension steel. So listen, for all these three varieties of steel, there is no change in yield stress. Yield stress remains same for all these grades. So it is same as standard equality steel. 250, 240 and 230 megapascal. In high tension steel, we have Fe 570, which is having yield strength of 450, 430, the thickness of this 20 to 40 mm. If thickness of this member is more than 40 mm, it is 420 megapascal. Whatever the yield strength I am writing here, it is megapascal, or we can say Newton per mm square. So these are the type of structural steels and their corresponding yield strengths. Please note that the yield strength of the structural steel is dependent of its thickness. Thickness is going to govern the yield strength of the material. Less is the thickness, more is the yield stress. Please make a note of this. Thickness of the element, structural steel section, if you take I section, which is made of standard quality steel, whose thickness of the flange or web, let's say, is less than 20 mm, then its yield strength is 250 megapascal. If thickness is 20 to 40 mm, it becomes reduces from 250 to 240. The thickness is more than 40 mm, it will be 230 megapascal, which means that if the thickness is less, yield strength is more. If thickness of the material is more, yield strength decreases. So please understand, what does it implies? What does it mean actually? When you have more material, more thickness, let's say, if there is a more thickness, more amount of material is there in that, there is a more chance of having weak spots. Higher the thickness, higher will be the chance of having the weak spots. So thereby the material is going to fail easily and material has reduction in strength. So thinner elements are having high strength, please understand that, than the thicker elements. That is what you have to understand. Okay, fine. So these are the yield strengths of the structural steels. What are their ultimate strength? Ultimate strengths are given here and the yield strengths are this. Whatever you see here is the yield strength. And please remember, some of the competitive examinations, they are not going to tell about yield strength, but simply they will give only grade of the steel. From the grade of the steel, you should be in a position to get the yield strength of their steel corresponding to their thickness of this section or element. Okay, I hope you understand this. So this is how the yield strength of the structural steel is given by our IS 800 2007. I hope it is clear to every one of you. Fine? Okay. Now, let us talk about what are the advantages of steel structures when compared to the reinforced cement concrete structures. Then we will be talking about what are the hot rolled steel sections, what are their practical applications. We will talk about them afterwards. Okay. Now, let us talk about what are the advantages of steel structures. Let us look at that. So, advantages of steel structures over reinforced cement concrete. Advantages of steel structures over the reinforced cement concrete. Let us see them one by one. So, what are the advantages of steel structures? Very simple. Steel is a high strength material. Basically, steel has higher strength. It's a very, very important point which you have to understand. Steel has higher strength. Very important. By nature, it's a gift for us. Steel is having higher strength. How it is? How can I say higher strength? Very simple. You take M20 grade concrete for that matter, if you want to understand it. If I take concrete, essentially we have a least grade of concrete of M20 for structural applications basically. Its FCK is, M20 means what? Its FCK, its strength is 20 megapascal. And steel, when I talk about steel, the least grade of steel available is Fe250. What is its yield strength? its yield strength is 250 megapascal. Okay, this is the strength of the steel, this is the strength of the concrete. So when I compare, least strength of concrete is 20 megapascal, least strength of steel is 250 megapascal. See, which means that steel is having higher strength, see, when compared to concrete. How much? Look at here, 250 by 20. You will get around more than 10 and up to 12, let's say. 12, exactly. 10 to 12 times higher strength the steel is having when compared to the concrete. We can say that is the what. So steel is a high strength material by nature. Please understand it. Don't get a misunderstanding of concrete of this much thickness is stronger. No, it's not like that. I am talking about material wise. So material wise, steel is very stronger than the concrete. Okay, and steel is ductile material. We'll talk about that after this. So because steel is having higher strength, what is the advantage of having higher strength? When a material is having higher strength, it requires lower cross-sectional dimensions. So high strength material requires smaller dimensions in order to resist a particular load. So high strength material requires smaller dimensions. So smaller dimensions are sufficient to resist a particular load. Smaller dimensions are sufficient to resist loads, particular load. To resist a particular load. So smaller dimensions are sufficient to resist a particular load. That's why aesthetics of this is very nice when compared to concrete. So smaller dimensions are going to be good aesthetics. When you look into a building, when you enter into a building where you have deeper beams, larger depth beams, you will not feel like to go inside basically. Aesthetics plays a vital role. So nowadays any construction you take it. Okay, what happens? So basically everybody want to have pleasing environment in their home. Basically they focus on the architectural aspects as well, right? So that's what. So we can have smaller dimensions which is going to improve the aesthetics of structure basically. So steel structures are aesthetically looking good when compared to RCC. That is the one thing. One more thing is that strength to weight ratio. So when I talk about strength to weight ratio of steel, strength to weight ratio of steel is much greater than the strength to weight ratio of concrete. Strength to weight ratio of steel is much greater than the strength to weight ratio of reinforcement concrete. So which implies that steel is having less weight. So please understand this point carefully. By nature steel is having less weight and it is having high strength. Altogether numerator is more and denominator is less. The entire ratio is high. That's what. Strength to weight ratio of steel is much greater than the strength to weight ratio of RCC. Therefore, we can have lesser dead loads in case of steel structures, less self weight and good aesthetics. That is the another advantage of steel structures. Now, very important thing what you have to understand is that a ductile material, steel is a ductile material. So ductile material, steel is a ductile material. We can say that if it is a ductile material, no chance of sudden failure. I can say that. No chance of sudden failure. That means you can never expect sudden failure in case of steel structures. But in case of concrete, reinforced cement concrete, concrete is a brittle material, fine, we know that. If you go for over reinforced sections in RCC, the section becomes brittle, it is going to crack and it is going to fail. That is the problem with RCC structures, which is not the case in case of steel structures. No chance of any kind of sudden failure in case of steel structure because steel is a Ductile material. So how would you say steel is ductile material? For that, let me explain. So what is the measure? I can say here that percentage elongation. So percentage elongation is measure of ductility. Percentage elongation is a measure of ductility. Which is a measure of ductility? Percentage elongation is a measure of ductility. So let us find how to find percentage elongation, and accordingly how do you define the ductility, brittleness? Let us look at that. So the performance of a particular material, behavior of a particular material, whether it is a brittle, ductile or intermediate ductile, if you want to define it, so basically we have to find out percentage elongation. So let us look at that percentage elongation. Percentage elongation. So how would you find the percentage elongation? Very simple. You take the steel bar, let's say this is the steel bar we are having. This is steel bar. Now you apply the tensile force on the steel bar, what happens? So when you apply tensile force on the steel bar, it undergo elongation. So there is an increase in the length of the bar. When you stretch it, there is an increase in the length. So when you stretch it, then there is a deformed length we can have. Here, this side also we have deformed length. So the final length after stretching, let's say this is the LF, final length, and the initial length when it was not stretched, when it is there at the same state of length, that is what we call L naught. So because of application of tensile force, there is a final length which is increased length and initial length is L naught. Then we will be finding percentage elongation. So if you find percentage, what is the percentage elongation? So the percentage elongation is equal to what is the change in length. So final length minus initial length by initial length into 100, that will give you the percentage elongation. This percentage elongation we are taking as a measure of nature of the material. So please understand, my dear friends, if this particular percentage elongation, I can write every time PE from now onwards, percentage elongation PE is less than 5%, for example. The percentage elongation is less than 5%, then such kind of materials are called as the brittle materials. We call them as what materials? Brittle materials. Whereas the percentage elongation is in between 5 to 15%, such kind of materials are called as intermediate ductile materials. What materials? Intermediate ductile materials. We call them as intermediate ductile materials. Fine. If the percentage elongation is more than 15%, such kind of materials are called as ductile materials. What materials? Ductile materials. So this is how we are going to classify the nature of material based on the which parameter? Percentage elongation. If percentage elongation of any material is less than 5%, it is said to be brittle material. If it is in between 5 to 15%, intermediate ductile material. If it is more than 15%, it is said to be a ductile material. That is how we categorize the nature of material based on the parameter called as percentage elongation. Fine. Now, steel you take, as I told you, structural steel especially, as I discussed so far, any structural steel you take it, their percentage elongation is more than 15%. So all structural steels are ductile materials. So I can say, very important thing, all structural steels, I can note, I can say structural steels are ductile materials. So structural steels are ductile materials. Structural steels are, I can say, structural steels are ductile in nature. Okay. Concrete, for that matter, it's a brittle. People say quasi-brittle material. Glass is 100% brittle material. Glass has almost 0 point something. That's why it's a brittle material. Glass is example for 100% brittle material. Okay. I hope you understand. Okay. This is another advantage of steel structure basically. So I am basically talking about advantages of steel structures. These are the advantages we are having. Higher strength, small dimensions are sufficient, good aesthetics we can have. Same thing, higher strength to weight ratio, and ductile material. There is no chance of brittle material. Why it is ductile material? What is the measure we have taken? Percentage elongation is the measure. That is what I talked about. Then after that, I explained about how it is ductile material. We are going to test a material, take a material, whatever you want to decide, nature, and apply tensile force, measure the percentage elongation. According to the percentage elongation, we can say what kind of material it is. Okay, fine. Then after that, now let us talk about another advantage. The steel structures has 100% scrap value. What does it mean? Steel structures have 100% scrap value. What is the meaning of scrap value? That means reusability. So steel has 100% scrap. That means it can be reused with 100% efficiency and strength. Steel, especially after dismantling, for example, steel you dismantle and you want to throw it, let's say. What you can do is, otherwise, suppose you constructed one, for example, one kind of automotive shed, let's say, automotors shed, then you want to shift that particular steel structure from one place to another place. Very simple. Take or remove the bolt material in the connection, take the section and use the same section some other location and you construct the same kind of shed. That is possible in steel structure because steel structures are transportable from one place to another place. But once you dismantle, especially in case of RCC structures, when you dismantle it, that's it. When you dismantle it, it cannot be reused at some other location in case of RCC. But that is not the case in steel structures. Steel itself has 100% scrap value. After dismantling of steel elements, we can reuse them at some other location with same 100% efficiency and strength. And we can recycle also steel even if it is, okay, that is what we can observe especially, right? And coming to the steel structures, basically strengthening of steel structures can be done easily. Strengthening of steel structures. Strengthening of steel structures can be done easily. What is the meaning of strengthening? Very simple. If I have a frame, basically I have a frame, for example, I have a frame, existing frame, and which has some capacity. It has some capacity. So this capacity, let's say we have 5 tons, it can carry, let's say, 5 tons of load. But I wanted to increase its capacity to, let's say, higher. Then I can go for, what I can do is essentially, I can weld or I can bolt to this section, or I can go for welding and I can have connections. Then I can improve the capacity, load carrying capacity. How can I do that? This is what? Additional sections are welded to the existing section, or similar identical sections are placed nearby and we connect to the existing section. What happens is, when compared to this one, this has more area because additionally we connected additional sections to the existing section. So area of all these members are increased. Cross-sectional area increased, moment of resistance also increased, bending moment capacity also increases when there is a moment of increase, when a moment of inertia increases. Very simple. Take the best example of moment of bending moment formula. M by is equal to F by Y is equal to E by R. Moment carrying capacity is equal to F into I by Y. So, more moment of inertia, more will be the moment carrying capacity. Less moment of inertia, less will be the moment carrying capacity. That's what you have to understand that. So that is how we are going to improve the load carrying capacity of this existing. It may be, let's say, 12 ton. So strengthening of steel structures, existing steel structures can be done easily just by welding or attaching additional sections to the existing section. But strengthening of reinforced cement concrete structures is not that easy. It's not like steel structures. Very difficult. We can do strengthening of reinforced cement concrete structure, but it's not that easy. It requires a lot of skills and investment is more, and we are not sure whether it is successful or not. Okay, whether it is going to be success or not. That is the problem we are having. So, but you can go for strengthening of steel structures. It's a very easy process. Another thing is that steel structures are airtight and watertight. Steel structures are air and water tight. That means they are waterproof as well as air proof. That means look at LPG cylinders at your home, like so we can store that gas inside the cylinder, and cylinder is made of what? Steel. So very important thing is that provided that the connections are welded connections. So when you make a welded connections, then the structure is air proof as well as waterproof. Look at water tanks. In summer seasons especially, you will be finding that there is a scarcity of water. In that in those times we will be finding that water tankers will be used to supply the water. So look at the water tanker construction, essentially all those connections are made of welded connections, so that water leakage will not happen. Okay, that is what it is. So that is how welded connections work. So provided that connections are welded, provided connections are welded, provided that connections are welded, provided that connections are welded. Okay, I hope you understand this. Fine, that is how, okay, these are the advantages of steel structures. There are many advantages as well in addition to that. But there are some drawbacks also we are having. What are the drawbacks of steel structures? Drawbacks of steel structures is that they are having less fire resistance. Fire resistance is less, but anyhow steel can sustain about 750 degrees Celsius. So that much temperature occurrence is very, very rare, but psychologically people feel that steel is having less fire resistance. That's not a matter actually. And steel may be susceptible for corrosion attack, that is the problem. But nowadays we have advanced technology in steel industry, we can have even corrosion free steel also we can produce, that's not a deal. But major problem is that we have what we call more initial investment. That is the biggest problem we are having. Initial investment is high for the construction of steel structures. That is the biggest or challenging task we are having in steel structures construction. So that is the major drawback we are having. Apart from initial cost, everything is advantage in case of steel structures. And we can have good quality. Another advantage is that we can say all homogeneous, isotropic and assured quality. We can have good quality and assurance we can have in case of steel structures. That's not possible in case of RCC, right? That is the problem. RCC is a composite material, and very important thing is that this particular steel material is having longer life. That is the biggest advantage we are having. Longer life when compared to the RCC. Typically, if the steel structures are well maintained, they can have a lifespan of 100 years if they are well maintained. Okay? But in RCC structures, typically it is 60 years. That is the typical lifespan of RCC structures. But we can say that is double the lifespan. So steel structures are having almost double lifespan than that of RCC. That means for the same structure, if you are constructed with RCC, you have to dismantle it again and you have to go for new construction. But one structure is sufficient to survive for 2 times when compared to the RCC because it has longer life. That is the basic advantage of steel structures. Okay, and we never find any catastrophic failure or sudden failure, provided that the connections are also bolted. Welded connections, there is a very we can say that we cannot able to exactly predict the welded connections done because we don't know what are the internal defects. Practical applications, we try to rely more on bolted connections than welded connections. It doesn't mean that welded connections are not good. Welded connections are good as well, but finding good or exact strength of welded connections may not be possible because internal defects, air voids, we cannot find actually with the help of welding basically with our available technology. Fine. So that's all about advantages of steel structures when compared to the RCC. So in the overall sense, we can say that we can have good quality assurance and the factor of safeties for steel structures are less when compared to RCC. Typically, if you look at concrete factor of safety, if you take it is 1.5 for concrete, for steel the factor of safety is 1.15 in RCC itself, both. Concrete and steel factor of safety, if you compare in working stress method, concrete factor of safety is 3 if it is working stress method and steel factor of safety is 1.78 and limit state method if you take concrete factor of safety is 1.5, steel factor of safety is 1.15. See, steel is having less factor of safety because it has reasonably good quality assurance and steel is produced from controlled conditions. That is not the case in case of concrete. Concrete will mix it, manual involvement is more. Even though you go for ready mix concrete, there are some kind of even unreliabilities are there, uncertainties are there. That is what the problem with concrete. Okay. So I hope I explained about all advantages of steel structures when compared to the reinforced cement concrete. Okay.